Hello friends, today's question. A pendulum clock loses 12 seconds a day if the temperature is 40 degrees centigrade and gains 4 seconds a day if the temperature is 20 degrees centigrade. The temperature at which the clock will show correct time and the coefficient of linear expansion alpha of the metal of the pendulum shaft are respectively. So in this particular question, it is given a pendulum is there and which gains or loses as the temperature is going to vary. So in this case, we are going to use two formulas. First is the basic one, that is the time period of the pendulum, and the other one is the effect of temperature on the length. So let us start with the time period of pendulum. So we know the time period of pendulum if it is represented as t, then t is equal to 2 pi L upon G, where this L is the length of the pendulum and G will be the acceleration due to gravity. And the second formula is the effect of temperature on the length. Effect of temperature on length, which can be written as L prime is equal to L naught 1 plus alpha delta t, where L naught is the original length, it is the original length at some reference temperature, original length at the reference temperature alpha is a coefficient of linear expansion, and delta t is the change in temperature. And L prime is the new length which represents the effect of the temperature on the original length, that is our L naught. See, L prime is our new length. So let us call this as equation number 1. So using equation 1, we can find out what will be the effect of change in length on the time period. Using equation 1, the effect of length change on time period. The effect of length change on time period, and we can represent it in the fractional form. So we can say the fractional change in time period, that is our delta t upon capital T will be equal to, or we can say related to, the fractional change in the length. And we are given the errors in the timekeeping. In the first case, it loses 12 seconds when the temperature is 40, and other day it gains 44 seconds when the temperature is 20 seconds. So we can call them as timekeeping errors. Timekeeping errors so that we can say that the clock loses or gains the time period or time based on whether the pendulum's time period increases or decreases. So we can say the clock, or we can say the clock loses or gains time based on whether the pendulum's time period increases or decreases. And total time error, that is, let us suppose it is delta t, you can say total time error if it is represented as delta t over a entire day, this can be written as that of a delta t will be equal to change in temperature divided by original temperature and total seconds inside the day, because the error that is being given is in seconds. So we can say this is equal to 86400. So let us define the reference temperature, and we say that the temperature at which the clock shows the correct time is T0. Let's call that as a reference temperature. So we say let the temperature at which the clock shows the correct time is T0. And we also say that at this time the pendulum length is L0 and the time period is T0. And let us express the time errors. Express the time errors, and we have two temperatures. First is at 40 degrees centigrade. So here the change in temperature, that is delta T, will be equal to 40 minus T0, and the clock loses 12 seconds per day. So we can also write that this is our change in temperature. Similarly, we can find out the fractional change in length. Fractional change in length, which can be written as delta L upon L will be equal to alpha, and this comes as 40 minus T naught. And next we can write the fractional change in time period. Fractional change in time period, and which can be written as delta T upon T is equal to 1 by 2, and the fractional change in length, that is delta L upon L, which will be further written as alpha 40 minus T naught. And the time error in this case is it loses a 12 second. So we can write that the time error in this case it can be written as that delta T is equal to 1/2 alpha 40 minus T naught multiplied by 86400 is equal to minus of 12, because there is loss of 12 seconds. Okay, so negative is only for the loss. Similarly, we can write same equations for the temperature of 20 degrees centigrade. So first is our change in temperature, that is our delta T will be equal to 20 minus T naught. Next is fractional change in the length, delta L upon L, which will be equal to alpha 20 minus T naught. From here we can write a fractional change in temperature, that will be equal to 1/2 alpha 20 minus T naught. And finally we can write out the time error, which is our delta T, and that will equal to our 1/2 alpha 20 minus T naught multiplied by our 86400, and that will be equal to plus 4, because it gains 4 seconds. Now we are going to solve both equations, that is, let us call this as equation number 2 and this as equation number 3. So we can see using equations 2 and 3, using equation 2 and 3, we get that our 40 minus T naught divided by 20 minus T naught will be equal to minus 12 upon 4, and the right side becomes minus 3. And now it is simple calculations. So we can write this as 40 minus T naught will be equal to minus 60 and plus 3 times T naught, and this gives us 4 T naught is equal to 100, and this gives us that a T naught will be equal to 25 degrees centigrade. So at this temperature, that is 25 degrees centigrade, we are going to get the correct time. And we have to find out the coefficient of linear expansion. So we can use any of the equation. We simply put T naught is equal to 25. So let us use equation number 2 from question 2, we can say our 1/2 alpha 40 minus 25 and multiplied by 86 400 is equal to minus of 12, and this gives us that our alpha will be equal to minus of 12 multiplied by 2 divided by 86400, and this is our 15. And from here we can say our alpha will be equal to 1.85 into 10 to the power minus 5. So this is our value of alpha. So we got both the temperature value as well as alpha value, and let us check the options that are given to us. So the option number A is the correct option. So we can say option A is correct. Option A is correct. This completes the question. Thank you.